So this video is on archiving files and compressing them. In Windows, we just use zip to do all those things. But Linux has a few different tools that are used slightly differently. So in order to do this, first thing you want to do is get a USB drive, one that's preferably pretty small. And honestly, if you probably won't have one small enough to do this, to follow along entirely, but that's okay. You can practice with, copying some folders or whatever, and get the general idea. And when you plug this into the host machine, what should happen is you might get something like this, and I say connect to Linux. If you're on a Windows machine, it might look slightly different, but it's the same idea. And it should automatically be mounted inside your Linux machine. If not, you know how to go in there and forcibly mount it. If you're looking at VM Player under Windows, you should have a little pull down arrow at the upper left hand corner, or if you're on VMware Fusion, you can click on Edit the Hardware. But I want to look at the memory, and you see right now I've only set up for 384. That's wrong. So hold on while I restart it and make sure that I have more memory. So once you've powered it off, then you can go back, and like I said, this is how it's done under a Mac, and I'm going to boost it up to a 1012 to give it 1 gig of space. And then I'm going to start it up again. Okay, so we're back up. I'm going to go to virtual machine and then USB and then connect to that device again. And it'll show up again. And now I'll have enough memory, I won't have to worry about it. I'm going to open up the command prompt, and now I'm going to do copy/media lbcc work star here. Oh, I forgot I need to, I think it's capital R for recursive. And now I have, there's only one folder there, the pics directory, but I have that here so I can work with that. Let's say that I want to, and if I do ls in pics, we see that it's got another folder called kittens and a JPEG called passwords.jpg. Suppose I want to take all of that and I want to archive it, right? In Windows, like I said, we would use WinZip. In Linux, we would use tar. So we would do tar and then dash. And tar is a little bit different. Come in close. Let me tell you a story. So way back in ye olden days, these big servers used to back up on tape. And there wasn't really a good system for getting the data from the server onto the tape. And tar was the program that solved that problem. It's short for Tape Archiver. So what tar does is it takes anything you give it, any files, folders, whatever, and it puts it in a certain sequence that's easy for a tape to understand, or that's easy to write to a tape. That's all it does. So I'm going to do, and because it's old, tar works a little bit differently than most of our more modern Linux command line commands. It forces you to list out the dash and then all of the commands in one switch. So I'm going to do dash and then create, and then C for create, V for verbose, F for file, and the name of the file I'm just going to call it archive.tar, and then I'm going to tell it pics. And so C means I want to create an archive, and I created one here called archive.tar. V means verbose. See how it printed out all the different directories and files that it found, right? That's because I gave it that V option. If you leave the V option out, it still does everything, it just doesn't print it out to the screen for you. And F for file. If I don't tell it a file, where do you think it goes? Standard out, right? And as a matter of fact, let's look at what that would look like. So this is what it would look like on my screen. And looks like a bunch of garbage characters because a lot of it's binary, and the standard out or the Xterm doesn't know how to interpret that for me. And we see now that when I do an ls, I have archive.tar there. So that tar file contains everything that was underneath the pics directory. And let me do this. Let me make a directory called temp. I'm going to move archive into temp. I'm going to go into temp. And I'm going to pull all the files out of archive.tar, and I'm going to do that with tar-ex for extract, verbose, because I wanted to print everything out to the screen, file, and then archive.tar. And it showed me everything that I extracted, and if I type ls, now we have the pics directory, and underneath that we have everything we would expect to see there. All right, so tar creates an archive. You have to give it the C option to create, the F option to give it a file. Otherwise, it expects to use standard in, standard out. So now we see archive.tar is still here. So when I extract it, it doesn't actually go anywhere. But that is, so it's taken all of those different files and directories and made it into one file, which is much easier to transport, but it's still not compressed like you would get with a WinZip. To do that, there are two tools that we commonly use in Linux to compress it. One is gzip archive.tar, and when you use gzip by default, it changes the file name. So it actually alters that file. And if I do file archive, it now tells you that it will, that it is compressed data, right? With gzip. And if I do g, so how would I unzip it? G unzip. And we see it's back to archive.tar. The other common tool is bzip. Oh, which apparently doesn't exist under Kali Linux, which is interesting. Bzip is a very common archiving tool. Some Linux derivatives don't have it. You don't technically need it. There are certain files that compress better with gzip. There are certain files that compress better with bzip. If you're absolutely trying to get the smallest file possible, it matters. For our purposes, it doesn't matter. Just know that both gzip and bzip exist. Now, one last thing. Let me go back to my home directory. Suppose I don't want to copy the files out of a USB drive. Suppose I want to copy the whole drive itself. For that, in Linux, we use something called dd. So dd actually takes the entire device and copies it. So if I do, if you remember, let's do ls/dev/sd. So the actual device is SDB1, and I can confirm that by doing mount with no options, and we didn't see down here at the bottom /dev SDB1 is mounted to media lbcc work. So if I want to copy that entire partition, then what I want to do is dd input file equals /dev/sdb1, and then output file equals, I'm just going to put it here, and I'm just going to call it junk.dd. And there are just a metric ton of options that you can do for block size and all, and read only and all this other stuff. We don't really care about any of that right now, right? I just want you to know, if you ever want to make a full copy of everything on the drive, you use dd. When I copy folders, it goes through the file system and just finds the names of folders and files and then pulls the data over. When I do a dd, it copies byte by byte, section by section. So I get everything. That's very important if you're doing like forensic analysis, because if there's a file that was created and then deleted, but the data is still sitting there, dd will copy that over. If you just copy the files using CP, it will not. And when DD is done, you see it tells me how many records in, how many records out, how many bytes, how long did it take. Because this is a very small thumb drive, that didn't take very long. If you're using a very large thumb drive, this will take a very long time. So you don't actually have to do DD for our purposes. Just know that it exists. Know that you point the input file to the device and the output file to whatever file you want to create. And if I do ls-lh, this shows you the size of files in a human readable way. You see that junk.dd is 117 megabytes because it's everything, it's every single byte from that thumb drive, which is a very small thumb drive. All right, so that is archiving files in Linux. Most commonly, you won't be archiving things. More often, you will be unarchiving things. There's a lot of software that's still distributed through tar files. Okay? If you have any questions, let me know.